All right, so dimensional analysis is a process by which, sorry, I thought I had the right page, where we switch units for the same quantity using factors that relate those two units to one another. So one example would be if you were going to the doctor's office and they said you were 6 feet tall, that would be the same as saying that you were 72 inches tall. If you look at different containers that contain foods and beverages, sometimes you'll see that they have, like for beverages, both the ounces and milliliters, and for more solids or things like that, they might have grams and pounds. And so those just relate two different mass units to each other, or two different volume units, and then the first example I gave you, two different distance units, or in that particular case, length. We can get these equivalent statements in part from that chart that I gave you earlier with the metric prefixes, and there's also a half sheet that Ms. Henshaw is going to bring you that will show you that no matter which form of centi, milli, or kilo you write, you're always going to see the same type of relationship expressed. Conversion factors are just ratios, and they can be written as with 1/2 of that equivalent statement in the numerator, or the other half in the numerator. But basically, one's in the numerator and one's in the denominator, and you use the one that makes sense for the conversion you're trying to complete. These conversion factors are defined quantities, so they do not have significant figures. So when you do your calculations with these, it's going to be based on the significant figures you had in your initial value. Sometimes you can do these conversions in one step. Other times you may require multiple steps. If it's a single step, it would be an example if you were going to drive from your home to another friend's home here in Winchester, you could do that as long as your gas tank had enough gas without stopping. But if you wanted to drive from your home down to Florida, you would probably have to stop to get gas because you're not going to be able to make it there in one direct driving pattern. You would have to have multiple driving events to make that take place. So these steps that we're doing, and I know that there are easier ways to do problems like these, but that we're going to do ones a little bit later this year that are a little more complex. And so learning this process with something that is more familiar to you is going to make your life a little bit easier. We always start by writing down whatever you're given in the problem, and then we set up that conversion factor, that ratio, so that our units will cancel. What we start with in the numerator needs to cancel out in the denominator, and then we keep doing that as many times as we need to until we have all the units that we need in our answer. We're going to then solve our problem mathematically and apply our sig figs and rounding rules. So in this first example, we are figuring out how many centigrams there are in 27.0 grams. So we start with what we're given, which is the 27.0 grams. And the relationship I put on there before, 1 gram equals 100 centigrams, allows us to connect those two together. Centi is always going to represent 1,000 of the unit in which it's being expressed. So since I started with grams, I need to cancel those out by putting them in the denominator, and the centigrams, which I'm trying to find, need to go in the numerator. If we look at that equivalent statement down here at the bottom, we see that there's 100 centigrams for every 1 gram. So the 1 goes with grams and the 100 with centigrams. At this point, my grams will cancel out, and I can multiply my numerator together, 27.0 times 100. I can multiply my denominator, 1 times 1, and then divide those two values. And that gives me 2,700. 27.0 has 3 sig figs because you have a trailing 0 and there's a decimal in the number. So if I want one of these zeros to be significant but not the other, I can put a line over that 0 to show that it is where the significant figures stop in that particular number. The other option I have is to write it in scientific notation, showing the 3 sig figs before the time sign. My next example is going to go from milliliters to liters. So milli represents 1,000, that there's 1,000 millis for every 1 liter. And so I'm going to use that conversion factor, or that equivalent statement, to set up my conversion factor for this problem. I'm going to start with what I was given, the 50.0 milliliters, and I'm going to convert from milliliters to liters. Again, I want the milliliters to cancel out, so one's in the numerator, one's in the denominator, and then I substitute my numbers in, 1,000 for milliliters and 1 for liter. The milliliters cancel, and this time when I multiply, I get 50 times 1, which will just be 50, and 1 times 1,000, which will be 1,000, and then I would divide 50 by 1,000. And that should give you, I believe, on your calculator 0.05. This has 3 sig figs, and I want 3 sig figs in my answer. The leading zeros do not count as significant figures, so I'm going to add 2 zeros past the 5 so that I start counting sig figs with my first non-zero digit, and I only get to count the zeros after my last non-zero digit, which happens to be the same one if there is a decimal in the number, and there is indeed in this problem. If I wanted to write it in notation form, it would be 5.00 times 10 to the negative second. My final example, at least for this part, there's another video that's going to do the other 3, is showing you what it is like when you have 2 conversions that you need to use because you have 2 different prefixes. The length of a book is 5.95 decimeters. How many millimeters is this? Deci represents 10, that 1 meter is 10 decimeters. And milli represents 1,000. Sorry about that. Hold on 1 second. Alright, I'll fix now. So 1 meter is the equivalent of 1,000 millimeters. And so we've got decimeters and we've got millimeters, 2 different prefixes, so we're going to need 2 different conversion factors. The first one is going to get us from decimeters to meters, the one on the left, and the second one is going to get us from meters to millimeters, the one on the right. So this is what I'm talking about by being a multi-step problem, where you can't necessarily get from the unit you're starting with to the unit you want to find in one step. You may have to use multiple steps to do that. Same thing happens with like time conversions involving seconds and days. You're not going to be able to get between seconds and days in one step. So these problems work the same way as the ones we've already done. You start with what you're given, and then you cancel out the units you want to start with, which in this case would be decimeters. And because we have a relationship here between decimeters and meters, meters go in the numerator. There are 10 decimeters for every 1 meter. And now the decimeters will cancel. And we are at meters. We're not done because we want to get to millimeters. So we need to cancel out our meters by putting them in the denominator at this point. And the relationship on the right will relate meters to millimeters. So I can put those in the numerator, represent that there's 1,000 millimeters in every 1 meter. And now my meters will cancel. I multiply across 5.95 times 1 times 1,000, which gives me 5,950. 1 times 10 times 1 gives me 10. So when I divide those, that gives me 595 millimeters, or 5.95 times 10 to the second millimeters. The second video will allow you to see the other 3 examples.